I think we should just get started. Because I have quite a lot of things that I would like to tell you, and where you can find resources and how you can get started the best way. So, my name is Christoph Wimmer. I'm actually with National Instruments. I'm there in a group that on the one side focuses on embedded control, and on the other side works very closely with national labs on the large experiments. And what I would like to give you here is an overview of LabView, how you can program LabView, and then as well how you can use it in combination with all the parts that you got for FTC, how you set up your system. So there's quite a lot of topics that I would like to introduce there, and we only have about 50 minutes because I want to give you time to ask questions as well. And then I would like to talk briefly about the training materials. Very briefly, so the idea is just for National Instruments that we just provide tools. And the idea is, in the end, you should choose the tools that are best suited for the tasks that you use. And there, one of the ways how to do that is actually with graphical programming, which you are considering of doing there. And so, if you're looking at LabView, and this is what you will be using for the programming, it's a graphical programming environment, and that's very important. So you will have a graphical representation of your program, which will help you to understand much quicker what's happening in your program, and it will also allow you much quicker to make changes to your program. This is also important if you have multiple people, and you should definitely have multiple people on your programming team, so that if one of the persons is getting sick for the competition, there is still a replacement who understands the code, who can make modifications to the code during the competition. So that's something that's really important, and that's just introduction. So you see here, that's SpaceX, you know, the rocket company. All their launch control system is based on LabView. So you're building something similar here, like a launch control system, just for a robot. So let's get into it, what you should have received. Did everybody of you already download the software and install it? Yes, everybody? Somebody didn't? Okay. Just very briefly, where you can find the software, and you should really do this. If you go to the first Robotics website, you find the programming resources, and then you can go there. And I'm really sorry about it. My computer is super slow because it decided that he wants to do a virus scan. You still find here all the resources directly for the first tech challenge. And there is the download page. And the two things that you will have to install is, number one, the Lego Mindstorms and the competition toolkit. So these are the two things that you have to install to make the whole thing work. And that should give you already a very good start for the whole competition. So let's talk about LabView, right? What LabView is and how you program LabView. In general, when you create a program in LabView, it's called a VI. VI stands for Virtual Instrument, and VI always consists of two components. One component is the block diagram. The front panel, and one part is the block diagram. So the front panel is where you can create your user interface, so you can see values, you can display values. And on the other side, you have the block diagram, and there you write your code. There you put in all the intelligence about your robot, what it should actually do. And those always belong together. So they are always one part. So if we go then, oh, and the last thing I want to show as well, because that's also really important. Down here in those windows, you find the target settings. So there you see exactly where is this program running on. Is it running on your computer, or is it running on your NXT brain? So that's as well very important, and they can directly see how it's going to work. And let's skip the slides and go directly into LabView. So when you have installed it and you start LabView, this is exactly what you're going to see. And so what you're going to do is you create a program. And I'm creating now first a program just to give you an understanding how LabView actually works and how you program in LabView. And then we go into more specifics about the FTC program and what you need to consider there. That was really the worst time for my laptop to decide that it wants to do a scan. Okay, so this is normally what you get. For FTC, you will create a robot project, and there will be the FTC arm and gripper. So that's where you will be starting. But we just I want to show you just the standard way how to program in LabView. And so we're just going to create a VI, a virtual instrument. And if we create it, what we do get here are these two windows. So you see those two windows here. So one is the front panel, and the other one is the block diagram. And you can distinguish this very well because in standard settings you have this gray, and the other one is completely white. So to kind of work with LabView, in general, you have something like a tools palette. And so this tools palette allows you to switch between different ways how you can interact with your different components. So you have, this is a selector, this is a hand where you can change values, this is here you can enter text, this is a wiring tool that allows you to wire things together. This is that you have sort of a right mouse click, which is especially important on Macs, but you don't really have a right mouse click. This is where you can move the whole pane and do painting. You have here ways how you can color your whole block diagram, how you can color components and change colors there. You have a paint dropper, so you can extract paint from somewhere. And if I look here on the front panel, so then I have here pretty much the same tools. So that's the background between the tools, and those ones are you will be using. And normally it's set for automatic tool selection, so it selects automatically the tools that it thinks are the most appropriate ones. And we see this by this green light down there. So that makes it automatic. If I want to select the paint down here, I can just select that one and pick a paint and just color the whole thing. And so we'll find it. Oh, yeah, I can. Yeah, sorry. Anyway, so what I can do next is, if I look at what can I program and how do I do this and how do I normally get started? Normally you get started by just looking at your front panel and changing on putting different components on your front panel, and then create the program code for your block diagram. So if I make here a mouse click, right mouse click, and most of the things that in LabView actually work through right mouse click. So if you don't know any further, try right mouse click and you will find a lot of selection that you can do. And so what you see here, you have here a lot of different controls and indicators. And the idea behind controls and indicators is controls, you can put in a value, an indicator, you're displaying something. So that's a very important concept in LabView, and it's also very more important when you go to the programming side. So I can just drop down here one of those controls, and what I see directly in the block diagram, a terminal appears. And so this allows me to access this data of this front panel very easily. So, and then I can put down a graph, and I see here, for example, a waveform chart. I see here some Boolean values, string inputs. So I can just put down a waveform chart and put it here. And I see I get again exactly a terminal. So what we want to do now is put the intelligent code into it. So what we would like to do is, for example, multiply the input from the slider with a random number and then add 50 to it and display this on the waveform chart. Very simple. So how we can do this, here again, with the right mouse click, we will have access to all our functions. And these functions are grouped together. So you know exactly where to look for your functions. You see here, these are general programming functions. So these are what you have everywhere, like for loops, while loops. Are you familiar with loops? Who is not familiar with loops? Okay, we will talk about this briefly later. You have here numeric functions that you can choose, string functions, Boolean functions, all these kind of different comparison operators directly that you can use in there. You have here, of course, the NXT/IO, so you can directly access those ones. You have here different behaviors that you can directly integrate in a very easy way. There are the third-party motors that you can integrate, and then here is for the competition kit, and that's mostly for communicating with the how is it called? The FTC. Yeah, the field control system. Yeah, exactly. FCS. And this is very important. That all the templates that you're going to get will have those built in, and those are really important. You will have to have those functions like in the templates, because otherwise you will not pass robot inspection. So what we said is we want to multiply this by a random number and then add 50. So you see here, we know that we will use at least 3 numerical functions in here. So what you can do is you can actually pin this here. So this will stay here and I can visualize it the whole way. It also helps if you have a second monitor to kind of display everything. You shouldn't make your programs too big, and we'll talk a little bit about that part. So what we need first is a random number generator. There is one thing that really helps you a lot in LabView, and this is if you press Ctrl-H. If you press Ctrl-H here, you get something that's called context help. And so with this context help, I can go over every function, and it tells me exactly what inputs do I have, what outputs do I have, and what does the function do. So if I go over the random number generator, so the random number generator produces a random number between 0 and the maximum number specified. And the max value, if I don't specify that, is the default is 100. So it will generate for me a value between 0 and 100. If I would like to have a value generate between 0 and 1, it would be, I would have to wire just up 1 to this input. So Ctrl-H, very important and will help you out. You can get much more detailed help. You see this question mark, I won't press it. But then you get detailed help on this function, or any function that you have. So I can just drop down a random number generator. And then I'm going to put down add and multiply and then add function as well. The add function. Just side here. So, let me explain how you wire. So how you wire is, if I go to one of the terminals, I see that it's blinking. So that's how I can actually start wiring. So if I click now, if I make now a left mouse click, it's kind of like soldering the wire to this function. I can see that I'm now dragging a wire, and then I can drag it to the next one. And if I have the help menu open, I see now I will connect it to the NXT input, which is the wrong input, output, sorry. And if I connect it down here to the random number, I can just connect it directly to this.
Could you show us what happens when you connect it to the wrong one?
Yes. So there is an undo. It's like Control Z, like always. If I connect it here to here, what you see now is you get this broken wire. So this broken wire means it does not work. And you see this right away. This up here is the start button, and I will go into that a little bit more. That's broken, so it tells me I have an error here. So I can just directly click on it and see, yeah, this is an unwired terminal. The multiplier contains you have connected two terminals of different types. So you get this information right away. You can click on it, and it shows you directly where it is. How do I get rid of it? There is also a very important function. So we learned Control H for the help window, Control B. Control B, it just gets rid of all these broken wires. So I don't have to click on them and delete them. I just click Control B and it goes away. So I click it here and I connect it over here. And so another important thing that I want to show with this example is how you can create just inputs. What I can do, of course, is I can pick here a numeric constant and just drop it in here and then use the numeric constant. Another way how to do this more elegantly and faster is that you make a right mouse click on this input and you see here create. And so you have three ways what you can do is you can create a constant, you can create a control, and you can create an indicator. In this case, we want to create a constant. If I would create a control, this would directly put an input on my front panel that I could modify and change. So if I create here a constant and enter here 50. So now I can just wire this up here and I have my full function. So what I can do now is I can run this program. Of course, you should save it first, which I don't. So what it does now, it always runs exactly one time. If I change this value here, it generates those random numbers. Questions? Should be rather straightforward and rather easy. So, yeah.
Did you say when you put that constant of 50 in there that it would put something on your form?
No. So if I would do it, let me.
If I want to specify that on the form so you can change that, what would you put on your front panel?
Okay, what you would do is if I could go here and create here a control.
Okay.
So now I have created here a control. This control is here.
Got it. Thank you.
And I can change it now here to 50. And I will get exactly the same results. So, what I can do next, so, yes.
Can you create your own functions in LabView?
Yes, of course. And I will show you how to do that. So, what you want to do next is kind of look at how can I execute this more often than once. I want to have this executing the whole time until I press the stop button. So, one way how I can do this is with loops. And I mentioned that briefly before. You have two loops up here. You have two different loops. This is the for loop. So what you see with the for loop, it has an n input, so it runs for n amount of time. So if you say, I want to generate 10 points, then you use a for loop, because it just generates 10 points, and you just wire up 10 to the n up there, and then it would execute exactly 10 times. On the other side, if I want to run it as long as possible as I want to until I press the stop button, I use the while loop. The while loop has two components in there. And one is the I, which always gives me the index, what kind of loop I mean, what round of loop I mean. Is it 0, 1, and so it just counts up and I can use it as a loop counter. And the second one is this stop condition that you see up here. And that tells me when should I stop it. If I wire something up to it, and I can wire, for example, a stop button very easily up to it, and then it will stop there. So if I use the while loop, and how you do it, you just select the while loop, and you see that the cursor also changes. And I can just drag the cursor around and just drop it there. So now I have created a while loop. And the only thing now what I have to define is actually when should it actually stop. So what I can do here is just create here a control as well, like we did before, right mouse click, create control. And what we should have here now is then the stop button. Okay? Questions? Good. So what would happen now if I start this? Just like this is. One thing is, what you have to consider is this will run now as fast as possible. So there is no limit. So whatever my computer can do, that's as fast as it will go. But I want to generate, for example, only 2 samples a second. So every second I want to have 2 new samples. So every 500 milliseconds I want to generate a new sample. So and therefore you have here on the programming side timing functions. And so these timing functions is I can just put in a wait and say, okay, wait here. And the input is in milliseconds. So we know that 1 second has 1,000 milliseconds. So if I want to do it twice a second, so I use it 500 milliseconds. So I generate here a constant that just waits for 500. So if I start this now again, you see that this is now running continuously. Now I can change this on the fly, of course. I can change this as well. So I can directly interact with my program. So what is important there is also the whole program flow. So what I can do here, LabView has very powerful ways how I can also look at debugging ways and how to work around. So let me just pause this here for a second. So what we can do now is actually, I've paused now the execution. So I have now the possibility to do single stepping through the application where I say, okay, I want to go now to the next step and what's happening here, and go inside what in this function is happening, and I can go out of this function again. So I can step into all these kind of functions and just step through my program. What I can do as well, if I go now over such a wire, I see it's a probe, so I can drop the probe so I know what kind of values I need. So I step over here. So we see now the probe number 3 is now 34. And if I go now over to the slider, it's now 69.38, and so on. So these are very powerful ways how you can debug your program and make it usable very easily. I'm going to stop this debugging. I can just run it again. I can still have my probes here and still visualize what's happening there. And that's something that's really helpful when you're creating a program that you know exactly what's happening. Question around that? now I can stop this whole thing, of course, with this one. Good. So the next thing I would like you to, what I would like to show you is how you can create programs, as we discussed before, that you can integrate into other programs. So that's a very easy way. You just select the part and you say, I can put this tiny side as well in there. So let me put that. And now I can create here a sub-VI. So a sub-VI is in general, if I create this, it just combines these functions into one new block. So you have now not one new block, and if you look at it, this block I can do a double mouse click on it, and it's again front panel, so a user interface component. And if I press Ctrl E, I get the block diagram. So what we learned was the Ctrl H, the Ctrl B for cleaning up and the Ctrl E to switch between the front panel and the block diagram. So I have exactly the same concept here again. And the great part, what you can do now, and you can't do this in any kind of other programming language, is I can test this directly without running the full program. So I can just go here and enter a value here and just run it and see what's happening just with this sub-function that I have. And that makes it also really powerful with programming. I can make the changes in this sub-program and give it to a friend or to another team or whoever. Let me just save this briefly. And the reason is because I would like to talk briefly about so what you see now here is the layout of the whole sub-VI. And this is exactly how it shows here. And what I can do, I can edit this icon, for example. And just modify it completely. There are some glyphs that you can use. I can add icon text there or templates. Oh, I have to install my glyphs, sorry. I can do some and of course I have here my different drawing tools that allows me just to draw something in here and make it okay. So I can just create a complete custom icon that is exactly put in. If I have now my help window open, I see, I get here input slides, I get in Y input, and I get out a numeric. So it's also really good that you name this pretty good. And where you say, okay, that's actually not Y. And so how you can change the name is just by double clicking on it. Larger. So if I have this now, I see it's an offset that I'm putting in there. So it's also really good that you really name your functions correctly. And if I go to the block diagram here again, I can add here some comments as well. So I can say here, by double mouse clicking somewhere, I can say creates random and adds offsets. This is also really good practice that you should consider when you're programming your application. The last thing I would like to mention there, in this case, is LabView is a graphical programming language that follows the data flow. So what does it mean? A function only executes if all its inputs are available. So this plus function only executes if it gets the value from the multiplier. The multiplier only executes if it gets the value from the slide and the random number. So it's data flow oriented, so the data flow directs how things are executing in LabView. That makes it very, very powerful. Oh, and one more thing that you can actually do, here in VI properties, you can actually find here documentation, and you can also add here number and adds set. So if I look now again at my VI, I get also in the help now exactly what this function does, and that makes it very, very good. So let me save this and close it. So what I can do next is actually, I want to, for example, create a function that blinks every second in LabView. So I do this. I drop down again a while loop. That's the other part, really important thing in LabView. I can have things running in parallel very easily without thinking about how these actually run in parallel. I drop down a second function. I know I want to run it every second, so I use a time function. And every second, that's exactly 1,000 milliseconds, so I just enter here 1,000. And I want to display an LED here, for example. So I drop down here the LED. And now I just want to make it blink. So the easiest way is, whenever it goes through the loop, it just should invert the state of the LED. And how do I do this? So there is something called shift register, and I will show you some links later that talk a little bit more in depth what kind of are the advanced programming concepts. But these shift registers, you can just add here, and the only thing that we need to do is kind of initialize those shift registers. So I just take a Boolean value and just set it to true here, and then wire up this value to kind of display it, and then wire this through. So in this case, it would set it to true and run through here. In the next iteration of the loop, this value that goes out here will appear here. In this case, it will not change anything, so you will need to invert it. And how do we do that? There, I can do again a right mouse click here and say insert, and I can just select on the Boolean palette not function. So it just inverts it, just says not true, make it false, and that's pretty much it. So if I run now this application, there is one thing that I mentioned before briefly, is I have the error broken, and the reason for it that it's broken is that I see here that the stop button is required. So I can create here a control again, and I can control that both loops independently and stop them. So if I start this now, I see that my light is now blinking exactly at the rate of 1 Hertz. Yes, please.
You may get to this in a minute, and I'm sort of going to interrupt your presentation, but can you, at some point, how do we visualize the next brick? In other words, the next computer brick. I mean, how do we work with that
Yes, I will.
You're going to get to
Yeah, yeah, yeah.
Because
yeah.
I mean, because I get lost in terms of like I want to be able to tell, you know, like one of its outputs and one of its inputs and what it's, you know, what it's going to run a motor or what it's going to do something.
I will talk to you about this in 2 seconds. I'm pretty much done now. I have one more concept that I want to tell you, and then I'm done with that. So now the upper loop is stopped. I can also stop the lower loop, and now they're both stopped. And so what would I really need to do when I have this run before that one? At the moment, they're running really in parallel. And to kind of make this happening, that one thing is running after the other one, you have something that's called sequences. And I know this is now a lot, and I'm not expecting you to remember all this, because that's why I will give you links afterwards to the training materials that will help you further. But these sequences, I can just plug it down. It's the same way as the loops, but it looks like a film strip. So, and then I can add here just another, add a frame after. And I can just drag in here this function. And so what's happening now is first this is executing and then this is executing. Now I have a real order when something should happen. First we saw it how things can happen in parallel. This way it's how things can happen one after the other. And now I'm finished up. So you see it's blinking now. So if I stop the blinking, then I see now that the random number generator goes. Good. So as the next thing, I would like to go more into the competition side and what that means. So you have different things that you should consider. So you have your robot project. And that's how you will be starting. You have your schematic editor, you have your remote control editor, you have a sensor viewer, data viewer, and remote viewer. And then you have some specialized FTC features, especially for the teleautonomous mode. The graphical programming, what I taught you before, that's pretty much the only things that you need to know on the graphical program, how to use LabView. Now this is now all specific to the FTC software. So what you start off is by creating a program. It's exactly the same way as we did before. There are some other links down there that show you how you learn LabView. There are challenges that you can actually take that you can do, and you can look more into those ones as well as, for example, measuring the temperature, measuring the battery power on your system, creating a robot that just drives in a square, and how you would do that. So you start off with a new robot project. And this new robot project, you just select the FTC, arm, and gripper, and then you get directly this created. So it looks a little bit different. You get here an autonomous mode and the default configuration. The first thing you should do is connect to your robot. And so you have different ways how you can connect it to it. You can connect over Wi-Fi, you can connect over Bluetooth, or directly over USB. So these are the three main ways how you can directly connect to it. And then you can configure your robot. And that's the second thing that you should do. You should configure your robot that exactly represents how it looks like. And so what you get there, let me just show this. So let me just close all this. Create here a program. I'm selecting here the FTC arm to name it, give it a name. So this is also where you can create different kind of projects, depending what you do or different versions. So if you want to integrate new functions, it's always good if you are creating a new project, because then if that function doesn't work during competition, you can always revert to the older version. Say, oh, that doesn't work, the arm broke or something like that. Let's just do the original version that we did before and And one other thing that you saw before, and that's also really a huge advantage in LabView, is you don't have to deal with compile times, pretty much. So when I press the start button, it pretty much compiled already. If you're using any kind of other long programming languages, you have those compile times in between. That's pretty much 0. So this is what you're going to get. We have an autonomous mode with the default configuration for remote control, and then I would have to specify the NXT target and open my schematic editor here. And the schematic editor is really, really easy to use. So you can directly define what kind of motor do I have here. It directly shows it. I can define what sensors I have here, what kind of servo controllers I have here. And so I create my whole configuration for it. And what's also really good, I can test everything in it. So I have the possibility to test all the motor parameters, click on the motor, and say, of course, at the moment it doesn't work because there is not connected. But now I could just say, set the power level and do reverse and just go. So I can save that and close it. Now I have my schematics saved pretty much. Then I have two other things that I have included, the autonomous mode and then the general template for the teleop code. And if I open the autonomous code, this is how it looks like. And it tells you exactly what you should do. Autonomous code goes here. So this is where you say, okay, drive straight until you find a beacon and then turn right and go closer to the beacon, or however your autonomous strategy will look. This one up here, this is communicating to the field control system. And you should never remove that. This is how the field control system can disable the robot at any stage in the game. This is how they switch the node over from the autonomous mode to the teleop mode. And this one waits just until it's enabled from the field control system. If the field control system enables it, then your autonomous code gets executed. This one down here runs in parallel to your autonomous code and just waits. If it gets a disable signal from the field control system, then it executes this part. And that should have stop all motors. This should, whatever motor you have in your system, that should be stopped in here, because that's for safety reasons. And that will be also something that they will look at in this inspection. So this is an example from the autonomous code. So you're driving forward until you come to a sensor that's closer than 10 centimeters, then you brake, then it goes the gripper, then you drive backward for 30 seconds, and turn for 0.5 seconds, and then brake, and then you can integrate some custom functionality and open the gripper again. So something like that could go into your autonomous mode.
Are those a comment line? That's a user added, programmer added as well?
Exactly. So that's exactly as I showed you before with the just double mouse clicking on the diagram.
It's similar on those kind of the blue and the orangish line?
Oh, yes. You mean the gripper and the main drive, these things?
Those were added to those?
Yes, you can make a right mouse click on the line and say add label or view label, and then you can add those labels to all the lines. So whenever the line gets dragged around, this will stick with the line. So now we have done the autonomous. That was easy. So now we're pretty much done with that one. So now we just have to do the autonomous, the teleop. And so what I do then, just open the default configuration. And so you have the remote control editor. So the only thing that I need to do is there, let me open that one too, so you have an idea how this will actually look like. So the only thing that I need to do, in this case it's tank drive, so you have two joysticks to drive forward and backwards. You can have an arcade right and an arcade left. And so you can define exactly how you want to drive, what you want to do there. You have here 1 or 2 controllers, so you can also set it to 2 controllers. In that case, you can define then robot actions, so you, depending what kind of buttons you want to do, you can define then specialized functions, and these specialized functions, and I think that's actually something that's really interesting. So for example, you can say, move for a certain amount of time, 1 motor. And so what you can do is just, you press 1 button and just the gripper closes. Another thing is, you can create, say, any kind of function should be executed. So for example, if you create your autonomous function where it finds the beacon, drives up there, grabs something and drops it, you can just execute something like that as well in the teleop mode, just automatically. And then finally is the run program, and this is also then a way how you can test the whole thing, where you can put it in teleop mode and just start the test and really execute it. And it kind of circumvents all the functions that you built in there for the field control system. Because otherwise you would have to have a whole field control systems installed. With this, you don't have to. So. And so this is creating then automatically this kind of program. And you see again, this is the field control system that automatically enables and disables everything. Here you can insert specialized functions, and there is really good training materials how you can modify the teleop mode to do exactly what you want to do. You have the joysticks description, how you work with it, and very, very straightforward. So that's completely automatically generated, and you don't need to modify it or anything like that. So one last thing that I want to mention is all those functions, you can either execute them on the computer or on the NXT target. If you download it to the NXT target, you can't really debug it directly. You have to keep it on the computer, then you can do remote debugging and directly see what it does. There is some things to consider. USB is the best connection for it because it gives you instant feedback, versus wireless is a little bit slower because you have delay times in it. Okay. Question around that? So, trainings. So how can you get started and work with it? We saw there are these trainings materials directly built into the LabView software, and you can just start with those ones. But what I found actually really, really helpful, there is this Robotics website, and you get directly So if you go again from your community space, there is the LabView training, and you get to this website. This lists pretty much every way how you can get trained. So you see there is a short introduction to LabView, which is pretty much what you saw now, with modifications. There is this FTC training material, and this is, I think, very, very helpful. If you look at it, it's tons of web paths. So it really starts with how do you create robot projects, how do you do your schematic editor, how do you create line color code. Goes then into the R-Render, where it goes into the semantic module, connecting to these, then it goes into autonomous programming and autonomous example down here, and this starts 3, 4, and then it goes 5, 6, 7, and then here 8. And it talks about state machines, transitioning, shift registers, which I briefly touched on. It's really, really helpful, and I would really encourage you every evening just watch this training. They have some really good information. And then there are other training materials as well. There is LabView programming fundamentals that you can download as well. There is a LabView 101 video training that you can download that goes more into the LabView programming then as well. And there is a LabView hacker that how do you use it for Arduino, Connect, Leap Motion, Wiimote, and so on. And Waterloo Labs, there's also quite a lot of how you connect it to your iPhone. Okay. And the last thing I want to mention, if you have challenges, there are on forums, and you can just post there, and I would really encourage you, post your questions there. There are people constantly monitoring these questions from the National Instrument side. Other teams are monitoring these questions as well. And so it's a really, really good way to exchange information and get started. Questions? Or was everything clear? And really easy and straightforward? Yes, good.
So in the previous session that I was in, there was some discussion about whether a robot team should start out using LabView versus RobotC. And kind of one of the comments that came up is that there's a lot more FTC teams using RobotC than LabView. And I mean, is that, you know, because we're a team that's kind of coming from FLL,
yeah.
so we kind of got the graphical
programming
kind of
already, already that. So this is, I'm anyway probably the wrong person to talk to, because I'm biased. Honestly, I am, and I apologize for that. I was a C++ programmer before, and I looked the first time at LabView and I said, what's that? That's graphical. That's not how I program. I program C++. Then I started with National Instruments, and I learned LabView, and now I'm only using LabView anymore because I don't do that much programming. And with C++ and C and other text-based languages, you have to really keep up on top and work with it constantly. Otherwise, you lose the capabilities to really program it. And that's pretty much what happened with me. If you really look at it, so if you have good C programmers in your team, I would encourage you, go for it. It totally makes sense. If you have good LabView programmers in there, you should do it in LabView. We have this example, you might have heard about the Odin challenge. Not Odin, sorry, the street challenge where they had these autonomous vehicles driving around in the city. And the the third place, I think it was Owen College. And they were just beaten barely by an MIT team who was using C and had all these professors. And they had teams one was a chemist, another was a mechanical engineer, and another one was an electrical engineer. So we were a rather small team, and they were using LabView for it. And they said, for them, the advantage was that they could just get started at this programming language because it adds an additional layer of description. If you're looking at text, and if I look at a C program, I have to read through the whole C program until I understand what it does. So it makes it really hard to transfer the knowledge from one person who's writing the C program to another person. If I have multiple C programmers in there, it's no problem. If I have LabView programmers, yes, I can sort of, if I understand the concepts of LabView, I can understand sort of what's happening in there. And what I find also really interesting, understanding if it's a crappy C program, it's really hard. In LabView, you see it. If all the wires are going everywhere, you should always, when you're creating a LabView program, try to keep it on one screen size, if possible. Just create sub-VIs. It should work most of the time. It doesn't work always, but that's, and so it has some built-in restrictions that allow you a little bit better to create easier programs. So if you have LabView experience, I definitely would encourage you to use LabView. If you have C experience, I would encourage you to C. If you have neither, and you're starting just off, you will have an easier start on the LabView side than on the C side. But I'm biased, and I'm sorry about that.
Lunch is here.
Oh, lunch is here. Yes, please.
How well does LabView play with like revision control?
With
Revision control?
as well as everybody else, as any. So you can. There is directly source control inputs capabilities, so you can just do revision control there as well. And there are settings where you can say whenever I make changes, I have to enter some comments what changes I make. Yes.
What language is LabView running under the first, and is it possible to manipulate that?
Nope. No, it just directly creates binary code and compile code, and so it's just therefore you don't see speed differences that much between LabView and C programs. So it's really, if you're a very good LabView programmer, you can create as fast programs as in C, and vice versa. So. Other questions? Or lunchtime?
Thank you.
Good.
Thank you so much. Thank you.
Hey, and if you have any questions, I'm still here and can definitely answer questions. Thanks. You're welcome.
Thank you. That cleared so many things up.
Sorry?
That cleared so many things up.
Good. I'm really happy. That was kind of the point behind it.
Yeah.
And if you have any questions, just email us.
Yeah.
Post on it for